Let us look at question number 41 now. Consider the following statements. So let us look at statement 1 given to us. The examiner tells us that the solubility of AgCl in 0.1 molar AgNO3 is greater than that in pure water. Students, this statement is incorrect because AgNO3 will dissociate to give us Ag plus and NO3 minus, and due to the presence of this excess of Ag plus ions, the solubility of AgCl is going to decrease. So S1 is incorrect as we had seen before. Let us look at statement 2 now. The solubility of AgCN in 0.1 molar HCl is greater than that in pure water. So students, if we talk about the solubility of AgCN in presence of H plus ion, so we'll have AgCN first dissociating into Ag plus and Cn minus ions, and this Cn minus ions will now react with H plus to form HCl. So students, we know that HCN is a weak acid and the Cn minus will readily combine with the H plus ions which is present in the system to form HCN to establish this equilibrium. Students, due to consumption of the Cn minus ions to form HCN, this above equilibrium will shift in the forward direction, which will lead to an increment in the dissolution of AgCN. So the second statement is correct. Let us look at the third statement now. The solubility of AgCl in 0.1 molar ammonia is greater than that in pure water. Students, this statement is also correct. So AgCl will first dissociate into Ag plus and Cl minus ions, and the Ag plus ions thus formed will react with ammonia to form the diamine silver complex. So AgNH3 whole twice positive. Okay, so again we can see that the product formed in the first reaction is getting consumed in the second reaction. So this will also lead to the first equilibrium shifting in the forward direction. So S2 and S3 is correct while S1 is incorrect. So in the question, the examiner seems to be interested in the correct statements. So students, we have to mark option 3 as the correct answer to this question. Let us look at question number 42 now. Observe the configurational change which occurs due to flipping in cyclohexane ring. So in the first structure, we have both the methyl groups located at the axial position. So if the ring gets flipped, both these groups will be present in the equatorial position. So we can probably draw that structure. If you look at the second configurational change which is given to us, so we have the cis form. So if we try and draw the cis form can be represented as this. So now when we flip the ring, we get the cis structure again, in which the axial here becomes the equatorial here and the equatorial here becomes the axial over here. So if I talk about the constant involved here, we have K3 and K4 in the second conversion, and in the first conversion we already had K1 and K2. Now if we talk about the stability of these two structures, so in the first one both of them are located at the axial positions, while in the second one both of them are at the equatorial position. So students, we know that the substituents are more stable at the equatorial position, so the structure on the right will be more stable. So this will have a feeling of going in the forward direction. So the value of K1 shall be greater than K2, which implies that K1 upon K2 is greater than 1. And if we talk about the second configurational change, so in the first structure on the left, we have one group on the axial while the other on the equatorial, and on the right hand side, we have a similar structure in which one group is again on the axial and the other is on the equatorial. So these two structures are equally stable. So the K equilibrium value for this reaction will be equal to 1, and the value of K3 shall be equal to K4. Students, if you look at the options, we can clearly see that we have to mark option 2 as the correct answer to our question. Let us look at question number 43 now. Which of the following is the most stable carbocation? So students, we have been given triphenyl carbocation derivatives which are differentiated by the bonds connecting the rings. So students, if we look at all of these options very carefully, we can see that out of all these given species, the structure given in the third will be the most planar because of these bonds which hold the ring together in place. So this will be the most planar, and the carbocation here will be the most delocalized among these three rings, which is going to cause this to be the most stable carbocation among the given species. So students, we have to mark option 3 as the correct answer to question number 43. Let us look at the next question. Question number 44. Identify the reaction which is regioselective. So students, if we talk about the regioselective reactions, we can eliminate the options in which there is either a symmetric substrate or there is a reagent which causes symmetric addition. When these two conditions are present in the system, the reaction cannot be regioselective. So if we look at the options, we can see that in the first and the second options we have symmetric substrate. We cannot have regioselective addition in these cases. If you look at the third option, we have a reagent that causes symmetric addition. This will lead to the addition of two Cl groups in an anti-fashion. So this is also not a regioselective reaction. If we talk about the fourth reaction, this causes an addition of H and OH in Markovnikov style without rearrangement of carbocation. So we can see that this is going to lead to the formation of CH3, CHOH and CH3. So students, this is the regioselective reaction. So we have to select the fourth answer as the correct answer to question number 44. Let us look at question number 45 now. What will be the final product C in the given synthesis? So we have been given a structure which is first allowed to react with zinc heat in presence of methanol. Students, zinc causes E2 elimination of 2 Brs. So there will be a loss of Br2 in an anti-fashion. So if you look at the bromines which is given to us, we can see that out of the given bromines, this bromine and this bromine are anti to each other. So this will lead to the formation of a double bond here. So this is our product A. Now the product A is allowed to react with NBS. So the NBS will lead to the formation of a geminal dibromide. And when it is subjected to hydrolysis in the basic medium, OH minus dilute and cold, it is going to lead to the formation of a ketone over here. We know that geminal dihalides on hydrolysis, they lead to formation of carbonyl compounds. Okay. So this structure C can now tautomerize to give us an aromatic structure which is resorcinol, which will be present in the greater amount due to its aromaticity. So if you look at the options now, the examiner seems to be interested in the final product C. So the final product C is correctly represented in option 4. Let us look at the next question now.